Hi, everyone. I'm Jeff Wagner, the infrastructure lead at Open Force Field, and here's my June 2025 update. Nobody liked the old format of the infrastructure updates, and so I will instead, moving forward, be focusing on highlighting new or upcoming capabilities enabled by the OpenFF ecosystem. The first one that I want to mention is that we are adding support for the Naggle charges tag in our OFF XML files. This is currently in the final stages of approval as a specification change. And the likely way that this is going to look in OFF XML files is it will generally replace the toolkit AM1 BCC tag. And it will come, it doesn't matter what order it comes in, but it'll be one of the second level sections inside of the Smirnoff OFF XML file. It'll have a model file field that specifies a PyTorch model file. It will have a digital object identifier optionally, and that's where if this file isn't present on the user's computer, it can be fetched from this DOI. This will be a Zenodo DOI, so this should be publicly accessible from anywhere and pretty long-lived. And then a standard version tag. So yes, once the specification change is approved, this is likely going to be the format that force fields employing Naggle use internally, at least for this first generation. I've mentioned this a few times before, but I did want to highlight there's this new functionality called interchange.from OpenMM. It's no longer experimental for the most part. It's got pretty good guardrails to let you know if you're doing something dangerous or if something's ambiguous. And so I had just put together a quick example of using it to make a protein ligand system using the Amber 99 SB force field instead of our standard FF14 SB using our port. The thing that I want you to take from this is that this could be anything. You could be parameterizing lipids using OpenMM's force fields or something like that, or other components. But I just put this together as a quick example of something that we'd all recognize. So here in this top bit, we're doing all of the OpenMM calls. So we start with an OpenMM force field object. We create that using the OpenMM namespace, and we instruct it to load Amber's 99SB protein force field. We use that force field with an OpenMM topology to create an OpenMM system. And then this is where we use that new interchange.from OpenMM functionality. This is going to eat up that system that we just created using the OpenMM force field. It's also going to take the topology that was used to generate the system. It'll need positions, which you can get from a variety of places, but here, often in OpenMM, you'll have either a PDB file object or a modeler object. Here I'm showing how you'd get the positions from a modeler object. And then you need box vectors because it's a periodic system. Once we have the protein interchange, we go through the standard OpenFF ligand parameterization workflow. You've probably seen this a million times. And then there's a little bit of stuff, and I'll share a code example that you can just copy paste for every situation to get the non-bonded settings to match up if there's some things that aren't lined up yet. And then finally, we use this interchange.combine method to take the ligand interchange that we just made and combine it with that protein interchange to create the complex interchange. And I didn't show it here, but you're done at this point. You can do complex interchange.to OpenMM simulation, and then just add a DCD reporter and start taking steps. So this is really it. And here again, I'm showing using an older protein force field than we offer. You probably don't want to use that, but again, you could be using this for other components that can be parameterized by this OpenMM force field class. Um, so there's really a lot that you can do with this. And I would encourage folks to experiment. I think that there's a lot that's going to work out of the box. And if they find trouble, please report it on our issue tracker and we can build around that or document things better. And finally, one of the big milestones in the last month is the Evaluator 051 release. One minor improvement here was the update for Pandas 2, which should unlock some higher versions of Python as well. But I want to shout out Matt and the science team, that's Lily and Jen, and a lot of folks in the Shirts lab as well, for debugging this really difficult issue that we were having with property calculations, where we were getting some really big outliers. And thanks to a lot of folks really digging into it, we determined that it was something really complicated to do with DCD file interpretation. There's sort of a helpful behavior in MDTraj, that wasn't being helpful in this specific situation. But we got to the root of it, and it was really quite a rabbit hole, and we got it fixed. So big shout out to the science team, to Matt, to the Shirts Lab folks, to other people I'm probably forgetting. This was quite a hunt. Thank you very much. I'll take any questions.